Howdy guys, this video will cover the topic 1-2 solving equations with variables on both sides that we went over on Monday, August 31st, 2015. And for this video, we're just going to cover examples 1, 2, and 3. So let's go ahead and get to those examples. So let me see. Well, here's essential understanding of what we need to know by the end of 1-2. To solve equations with variables on both sides, you can use the properties of equality and inverse operations to write a series of simpler equivalent equations. Okay, so we need to know how to do this by the end of 1-2. So here's our first example. Here we go. Okay, solving an equation with variables on both sides. What is the solution of 5x plus 2 equals 2x plus 14? Now don't forget, you can pause and rewind this video if I go too fast or you need clarification, okay? So here we go. We first need to draw our line down the center of our equal sign. And when it comes to these types of equations, we need to always solve for the variable, which in this case it's x. But here we have an x on either side of the equal sign. So we can't just combine like terms. We have to use the properties of equality to move them so we can combine them. Alright, so we usually prefer the variables to be on the left side. So let's go ahead and take this 2x here and subtract it from both sides. Because it's on the opposite side of the equal sign, it's positive. To get rid of it, you have to use a negative. So minus 2x on both sides. And that's going to be the subtraction property of equality. Alright, so 5x minus 2x is 3x. Bring down the 2, so plus 2 equals, that becomes 0, and then bring down the 14. Okay, now this is very basic. Now just solve for the variable. So let's go ahead and we need to isolate the variable. So circle the term with the variable in it, and we need to get rid of whatever is next to that circle. So subtract the 2 from both sides. And again, that's the subtraction property of equality. Okay, so this becomes 0. Bring down your 3x equals 14 minus 2 is 12. So now we have 3x equals 12. And so finally, last step, to get that x by itself, we have to divide by the coefficient. So divide both sides by 3. And that is the division property of equality. So 3 over 3 is 1x, because that divides to 1, equals 12 over 3 is 4. So x equals 4. Alright, next question. This is going to be example 2. The previous one was example 1, sorry. Okay, so for example 2, we have 3.1x plus 9.2 equals 2.06 minus 1.15x. Again, draw your line down the center of equal sign, and we need to get all the variables on the left side of the equal sign. So circle this negative 1.15x, because that's what we need to move to the left side. Don't forget that the symbol in front of the term belongs to that term. So in order to get rid of this negative, get rid of the negative 1.15x, we need to add it. It's the inverse operation to both sides. So plus 1.15x. Draw your line, and that's going to be the addition property of equality. Okay, so then 3.1 plus 1.15 is 4.25x plus 9.2 equals, bring down your 2.06, and this adds to 0, so put a big old 0 through it. Now, very simple. All we need to do is get the variable by itself. So take the term with variable, circle it, and we now need to subtract. We need to subtract the 9.2 from both sides to get rid of it. 9.2 minus 9.2. Draw your line. That is the subtraction property of equality. So that becomes 0. 9.2 minus 9.2 is 0. Bring down your 4.25x equals 2.06 minus 9.2 should be negative 7.14. And finally, last step, to get the x by itself, divide both sides by the coefficient in front of x. So 4.25 we're dividing by. That'll divide to 1. So we'll have 1x equals negative 7.14 divided by 4.25 should be negative 1.68. So your solution is x equals negative 1.68. All right, oh, and this is the division property of equality. Okay, and then finally, last example, example 3, is a word problem. So it takes a graphic designer 1.5 hours to make one page of a website. Using a new software, the designer could complete each page in 1.25 hours, but it takes 8 hours to learn the software. How many web pages would the designer have to make in order to save time using the new software? So pretty much with these types of equations where you have a variable on each side, I just say it like this. You have your old data on one side of the equal sign, and then your new data on the right side. All right. So let's go ahead and find the terms of this equation. Let's find the old data. So we have old software that takes 1.5 hours to make one page. So 1.5 hours per page. And then we have our new software, which takes 1.25 hours per page, but it takes 8 hours to learn it, so an additional 8 hours. So it's asking you how many web pages would the designer have to make in order to save time using the new software. So our variable needs to be what we're trying to find, which is how many web pages. So I would say that our variable should be W for number of web pages. Okay, so let's go ahead and go back to our terms and turn them into mathematical statements. So 1.5 hours per page. So pretty much you're going to have 1.5 W. So 1.5 hours per web page equals 1.25 hours per page. So that'll be 1.25 W. So 1.25 hours per web page. But for the new software, it takes an additional, so plus 8 hours to learn it. So then plus 8. So lastly, all we gotta do now is just solve for W. So again, we need to get all the variables on the left-hand side of the equal sign because that's just what we prefer. So go ahead and subtract this positive 1.25W to the other side. That's the subtraction property of equality. So 1.5 minus 1.25 is going to be 0.25W. That'll add to 0. And so then we need to just bring down our 8. And last up, we need to divide by the coefficient in front of the variable to get the variable isolated. So divide both sides by 0.25. So that'll divide to 1. So we'll have 1W equals 32. Because 8 divided by 0.25, pretty much you're dividing by a quarter. And when you divide by a fraction, you can multiply by the denominator. So 8 times 4 is 32. All right, but this is the number we need, but not the actual solution, because this is a word problem. And word problems need our solutions to be in a sentence. So you could say, let's see, the question asks, how many web pages would the designer have to make in order to save time using the new software? You could say he would need to make 32 web pages in order to save time using the new software. So he would need to make 32 web pages in order to save time using the new software. And there we go. That's the answer. All right, guys. So thanks for listening and watching. See y'all in class.